video lecture is about Bronsted Lowery theory of acid and bases. In this video, we will discuss the Bronsted Lowery definitions of acid and bases, relative strength of acid and bases, and conjugate acid-base pairs. Why this theory was developed? There is an acid-base theory that is known as Arrhenius theory. According to that theory, acid is that species which donate the hydronium ion or hydrogen ion in ecosystem, and the base is that species which donate the hydroxyl ion in ecosystem. So there are some limitations of Arrhenius theory for acid and bases that are overcome by a more generalized concept that is known as Bronsted Lowery concept. Now, what are those limitations? It can only describe the acid-base chemistry in aqueous solution. So, acid and base will act as an acid and base in aqueous system. Although these acid-base reaction occurring in gas phase system also, but it cannot explain it in the other medium. It cannot explain the basic property of substances that do not contain the hydroxide ion. Now, according to Arrhenius theory, base is that substances which donate the hydroxyl ion. So, there are some species that does not contain the hydroxide ion. For example, ammonia, NH3. It does not have hydroxide ion, but it acts as a base. So, it fails to explain that species as a base. Bronsted Lowery definition of acid and bases. So, an acid is a species, molecule or ion that donates or tend to donate a proton. And a base is a species, molecule or ion that accepts or tend to accept a proton. Which means that acid is a proton donor. And a base will accept the proton, so it is a proton acceptor. So, there is a terminology known as proton donor and acceptor. It is used in this theory that is known as Lowery-Bronsted theory. Example is when hydrochloric acid, it will combine with ammonia, it will produce ammonium ion and chloride anion. Now, if we look at the reaction, hydrochloric acid will donate a proton and it will accepted by the ammonia, and the ammonia will form ammonium ion, and the hydrochloric acid, it will be converted to chloride anion. Now, the species which will donate the proton, that is known as acid. So, hydrochloric acid acting as an acid, and the species which accept the proton from an acid, that is known as base. So, ammonia here is a base. Hydrochloric acid is a Bronsted acid since it donates a proton to water, and water will accept a proton, so it will be a Bronsted base. If we look at the reaction of hydrochloric acid with water, hydrochloric acid will donate a proton to water. So, the species which donate a proton is known as acid, and the species which accept a proton is known as base. If we treat ammonia with water, so the ammonia accept a proton from water. Therefore, ammonia will be a Bronsted base and water will be a Bronsted acid. If we look at the reaction, H2O, water will lose the proton, and that proton is gained by the ammonia and it is converted to ammonium ion, and the water will be converted to hydroxide anion. So, water will lose the proton, so it is an acid, and the ammonia will gain the proton, so it will be a base. If we look at these two reactions, water will act as a base, as an acid. So, it means that water is amphoteric. Amphoteric are those species which act as a Bronsted acid as well as Bronsted base. So, water will be amphoteric. That is explained by the Lowery-Bronsted theory. Relative strength of acid and bases. Strength of acid and relative strength of acid. Strength of acid is actually the ability of acid to donate a proton. Relative strength of acid is actually the relationship of acid strength of one acid with other acid. So, the stronger acid are those which lose their proton more easily than other acid. So, it is the relative term. It means acid strength is related to the other acid strength. or the acid which donate a proton to the higher degree than other acids is known as relatively strong acid. If we look at the reaction of hydrochloric acid with water, the hydronium ion is produced and chloride ion is produced. Hydrochloric acid has more acid strength. It means it is relatively more strong acid than H3O positive. H3O positive will lose the proton and that proton is gained by the chloride ion and the reaction will go in the reverse direction. But if we look at the arrow, this reaction will not go to the reverse direction or very little extent to the reverse direction. It means that hydrochloric acid is a strong acid than H3O positive. H3O positive will lose the proton to the little extent as compared to hydrochloric acid. Similarly, strength of base and the relative strength of bases, the ability of a base to accept a proton is known as basic strength, and the relative strength of the bases, it is actually the relationship of acid strength, basic strength with other bases. So the stronger bases are those which accept proton more easily than other bases, or a base which accept proton to the higher degree than other bases. That is known as relative strength. Ammonia is a relatively strong base than water because it will accept the proton to the higher degree than water. So it is relatively a strong base than water. Conjugate acid base concept. Conjugate acid is a species which is formed as a result of acceptance of proton by a base, and conjugate base is a species which is left behind after the donation of proton from acid. So consider a generalized reaction. Here the acid, it will combine with a base and it will produce conjugate acid and conjugate base. Now how these conjugate acid and base are formed? When this acid, it will release a proton, it is converted to A minus, or the species that is left behind after the release of proton from acid. So it is known as conjugate base. Similarly, the conjugate acid, it is a species when a base take up a proton or when a base gain a proton, it is converted to conjugate acid. So every Bronsted acid has a conjugate base. So acid will have conjugate base and every base will have conjugate acid. So this is a base, so the next pair will be conjugate acid. In simple word, we can say when a Bronsted base, it will gain the proton, it will form conjugate acid, and a Bronsted acid, when it remove the proton, it will produce a conjugate base. Conjugate acid base pair. According to Bronsted Lowery concept, a reactant and product that is differ by a proton are known as conjugate acid base pair. Or we can say the conjugate acid base pair are the species on opposite side of an equation that is differ by a proton. Consider a generalized reaction of acid and base. So here it will produce a base because it is acid, so it will produce a conjugate base by loss of proton, and the base, the Bronsted base, will form a conjugate acid by gain of proton. So its next part will be the acid, its next pair will be the conjugate base because acid will produce the base, so these are known as conjugate acid base pair. The base will produce an acid in the given reaction, so it is also known as conjugate acid base pair. Weak acids, weak Bronsted acid will have strong conjugate base. So here a point is given, the weaker acid have stronger conjugate pairs and stronger acid have weaker conjugate bases, and the weak Bronsted base, it have strong conjugate acid. So these both are considered as conjugates. Here are some example of conjugate acid base pair. HCl, it will produce chloride anion. Hydrochloric acid, that is an acid, and the conjugate base is chloride anion. So these two are acting as a conjugate acid base pair. Similarly, the base H2O water, it will gain the proton and it will produce hydronium ion. So it is a conjugate acid. These both are considered as conjugate acid base pair. Similarly, in case of ammonia and water, water will act as a base and its conjugate, water will act as an acid and its conjugate base is hydroxide anion. Ammonia will be a base and its conjugate acid will be ammonium ion. So water and hydroxide ion are the conjugate acid base pair, while the ammonia and ammonium ion are the conjugate acid base pair. Identification of conjugate acid base pair. In the given reaction, how we can identify the conjugate acid base pair? So there are 2 points that need to be considered. Reactant and products that differ by a proton. So first we will look at the proton. If there is a difference of 1 proton, so they will be conjugate acid base pair, and the species will be present on the opposite side of the equation. So here the HCl, the next counterpart will be the chloride anion. So HCl, hydrochloric acid, will have proton, and the conjugate base, that is chloride anion, it doesn't have hydrogen ion or proton. So there is a difference of a proton. So these both are conjugate acid base pair. Similarly, the ammonia and the ammonium ion, these both have difference of 1 proton. So these are conjugate acid base pair. Similarly, the reactions of ammonia with water, it will produce ammonium ion, that is a conjugate acid of ammonia, and hydroxide ion, that is a conjugate base of acid H2O. Acetic acid, its conjugate base is acetate ion, and the water, its conjugate acid is hydronium ion. Hydrogen cyanide, it is an acid and the water will act as a base, and its conjugate acid base pairs are conjugate acid, that is the hydronium ion, that is the conjugate acid of a base, that is water, and hydrogen cyanide, it has conjugate base, that is cyanide. Similarly, the H2S, H2O. Now H2O water, it will combine with carbonates and it will produce bicarbonates and hydroxide anion. Now the water here will act as a acid and the carbonate ion will act as a base. So its conjugate acid will be the bicarbonate and the conjugate base of the water will be the hydroxide anion. In the next reaction, if we look at it, here the bicarbonate, it is an acid and the water will act as a base. In the previous reaction, water will act as a acid. Now water will gain the proton from bicarbonate and it will produce acid, and the bicarbonate will lose the proton, so it will produce a conjugate base.